Hello everyone, welcome to Antennas and Microwave Engineering lecture series. Today I am going to explain about M-derived filter, which is the continuation of the image parameter method, and we will discuss the MCQ questions also. Okay, so what is M-derived filter? M-derived filter is the derivative version of constant K filter. The constant K filter la rendu drawback irundhu. One is low attenuation rate, another one is non-constant image impedance in the passband. Okay, so these are the two disadvantages in constant K filter design. So that two disadvantage is overcome by using this M-derived filter section. Okay, right? Now this M-derived filter section, there also we can design for low pass filter as well as high pass filter. Is the low pass filter oda circuit, series inductor, parallel capacitor, but that is multiplied with the parameter M. M represent midpoint impedance. Okay, the first diagram will represent the T form representation. Series arm la pathinganna inductor anga L by 2 inga ML by 2 nu irukum, but in the parallel arm that is covered by two components. One is capacitor as well as the inductor, both are in series connection. Okay, so that's the formula you should remember. Sometimes in the question la enna kepanga appadina low pass filter M derived section la parallel arm la enna irukum, ஒரு capacitor series with the inductor or capacitor parallel with the inductor, like that they can ask, or otherwise they will give the formulas like inductor oda formula என்னவா இருக்கும், option A, like that they will give, and 1 minus m square divided by 4m into L, you have to click it out. So like that the question will come. Okay, similarly the T form represent this is the first diagram is the T form representation, second diagram is the pi form representation. Okay, and I told you previous videos itself, constant K filter போல இங்கேயும் M-derived filterலையும் T formக்கு தான் formula இருக்கு, and the same formula is applicable for pi form also. உங்களுக்கு ஏதாவது இண்டக்டரோட வேல்யூ எவ்வளோ அப்படின்னு கேட்டால் நீங்கள் இங்கே இருக்கிற ஃபார்முலாவில் யூஸ் பண்ணி எல்லோட வேல்யூ கால்குலேட் பண்ணிவிட்டு அந்த காம்பனண்ட்டில் எம்எல்லாம் எம்மோட வேல்யூவை மல்டிப்ளை பண்ணி you have to put it in the diagram. Okay, and these are the formulas to calculate the values. The first one is the characteristics or nominal impedance R0, which is equal to root of L by C. It's a constant one, and I told you, constant K filter laying K equal to root of L by C dam. So M-derived filter and constant K filter la R0 oda value equal. Then the cutoff frequency omega C equal to 2 divided by root LC, and inductor L equal to 2 R0 divided by omega C, and capacitor equal to 2 divided by R0 omega C. So this is somewhat similar to constant K filter design, and one of the new formula is midpoint impedance M, which is equal to root of 1 minus Fc divided by F infinity the whole square, where Fc represent the cutoff frequency, F infinity represent infinite attenuation pole. Okay, infinite attenuation pole. Okay, like that you have to remember it. And if suppose what's the half section will look like in the filter design means this is the half section. Okay, see, actually originally the format is M Z and 1 minus m square divided by m in the Z, then m y, that means the admittance. This is for low pass filter in T form. Okay, and how that M value is applied as well as that Z is removed as inductor and capacitor is shown in the second diagram. One half will consist of like this. Okay, ஒரு இப்போ low pass filter na first inductor, then series with the capacitor and inductor will come, and similarly high pass filter, that is something different, like instead of inductor in the series sum you will get capacitor. So like that the diagram will come. ஓகே, சில நேரங்களில் ஒரு ஹாஃப் செக்ஷனில் லோ பாஸ் ஃபில்டரோட டயக்ராம் எப்படி இருக்கும்னா ஆப்ஷன்ஸில் 4 டயக்ராம் கொடுத்தா யூ ஹாவ் டு சூஸ் திஸ் டயக்ராம். ஓகே, ரைட். நவ் the second one is the M-derived filter with the high pass model, high pass filter model, and this is the model. Here I told you, the capacitor is connected in series, and in the shunt arm capacitor and inductor are connected in series with the inductor value is L by M and capacitor value is 4m divided by 1 minus m square into C. So these are the circuit as well as formula present in the circuit you should remember. Okay, so based on that 5 formulas available, and the formulas for calculating in the high pass filter, the cutoff frequency omega c equal to 1 divided by 2 into root LC, and L inductor value L equal to R0 divided by 2 omega c, and C equal to 1 divided by 2 R0 omega c, and M equal to, that is midpoint impedance, equal to root of 1 minus F infinitive divided by Fc the whole square. இதே இது low pass filter எடுத்துட்டீங்கன்னா root of 1 minus Fc divided by F infinitive the whole square. It's a reverse proposal. Okay, right? So based on that, these are the formulas which are present in M derived filter.